All right, here it is, the factoring trinomials with a leading coefficient of 1. What does that mean, you might ask? That means that this number right here, the coefficient on x squared is 1, or there isn't one because we don't write the 1. So first thing is, while I am focusing on how to factor these out, I do want to show how I generally expand or like take these two sets of brackets that we have here, these two sets of brackets here, how we turn them into a quadratic and then into a trinomial. So the reason I'm doing this is so you know that I'm not giving you a trick like I have in the past where I give you something that's unsolvable. So I had you research the FOIL method, right? First outside, inside, and then the other ones. I actually found that more confusing. The thing is that as long as we're multiplying, as you can see here, these red lines, I'm going to start with the x. As long as I multiply each term, and remember a term includes the sign, by each term in the first bracket, it's going to work out all right. So I generally do x times the two x's, which is going to give me my x squared. Then I'll do the x times the second term in the first and the second bracket. And then I do the opposite like I have in the blue lines here. Okay, so you can see how I've broken it up. Now you also have to be aware that this system will always give you a like term with the two x's. So please, please, please make sure 100% of the time that you are taking the sign with that term. That's the biggest mistake students make when they're collecting like terms. So this one I have negative 3x and positive 4x. Before I jump into the ac+b technique, which is the one that I generally teach first because I think it makes the most sense, I do want to talk about what the letters are. So over on this side, this little box off in the corner. This box here explains that when we talk about a, b, and c in trinomials, the a is always the leading coefficient on our x squared term. Right? The b is going to be the coefficient on our x term. Right? So there's no exponent on it. It's just x to the power of 1. And c, what's the name of this? C is going to be our constant, just like in algebra. Okay, so c has no variable. Now in some of our equations that we'll get to later on, there's one called the factors of perfect squares, stuff like that. If we have something that is 4x squared plus 16, I have an a and I have a b. Oh, I don't have a b. You're right, Mr. Paul. I have an a and a c. The value of b, because I don't have any x term, b equals 0 in this case. Okay, so just keep that in mind. It doesn't even equal 1 because I have no x term. All right, good. Hopefully that made sense. If not, come and talk to me privately. So over here, we're going to just start with our trinomial that I've made based on this number 1. Okay, so the very first thing that we're going to look at here is we know, like if you look here, this is a leading coefficient of 1 in the middle term. So what that means is that these two terms that I combined, when I add them together, I have to end up with 1x. The other thing here is that because of this negative 12, where does that come from? That comes from when I multiply my two constants together. Okay, so that's the principle behind the technique that I'm going to show you in this little video. So I have my own notation, like I always do. Okay, I like to take things and simplify them. So this technique, we're going to look for something that multiplies together. So a and c are going to have to equal something, and then they're going to add up to the middle, just like we did here. So in this case, let's take a look. My a is 1. So this is going to be 1 times my c, which is my c again. Right, c is my constant, so it's going to be negative 12. So I get 1 times negative 12. I'm going to be working with negative 12. That's what they have to multiply together to equal. Now, why do we multiply a by c? Sometimes our leading coefficient over here is going to be something like 2. So if this was the trinomial I was trying to factor, 2 times negative 12 would give me negative 24. It changes things significantly. That'll be in, actually I have a video that a student made that I'll give to you there. So I know this has to multiply to give me negative 12. Now what is my b? This has to add up to plus 1. Now before you go any further, this is the next step I'd like you to start to think about, because there's 2 different ways to make negative 1. I could have a negative plus a positive, a bigger positive, or I could have a positive plus a positive. So these are the 2 options I have, right? If I have, like I have this one, this is going to be negative 3 plus 4. I know that's the answer, okay? But in this one has to be the right answer. Why? Because over here, what are the 2 ways where I can make a negative? Do I have 2 ways to make a negative when I'm multiplying? When I'm multiplying, that should be a plus there. There we go. Negative plus a bigger positive. Over here, I only have 1 way to make a negative, and that's a negative times a positive. So you see what's happening is that I've already started to narrow down what numbers I'm looking for. Okay, so that's just a little pre-thought that'll make your life easier. Now, if you have small numbers like this, the easiest way to do it is to just list the factors. 1 and 12, 2 and 6, 3 and 4. Right? Now, these are multiplied. So these are my factors. I'm going to show you later how to do it with prime factors, which is my preferred method, but we'll start with this. So let's start adding up. So these all multiply. One of these has to be negative. I know that. And if we check over here, this side would have to be negative. The bigger number has to be negative. So now we do the check. These all equal 12, negative 12. But which one adds up to positive 1, right? Because that's what our b value is. So the first one, 1 plus negative 12, that gives me negative 11. Well, that's not right. 2 plus, see why I'm adding them? Because they have to add up to negative 1. 2 plus negative 6 gives me negative 4. That doesn't work. 3 plus negative 1 gives me negative 1. Uh-oh. Didn't work out. I've got negative 1. What did I do wrong? Yeah. It should have been the other way around. The plus had to be positive. I even identified that over here. But what did I do? I screwed up over here and I made these ones negative. So it should actually be this side that was plus. Plus. All right. So here, if I go negative 3 plus positive 4, I get positive 1. Is that what I'm looking for? That's the money. That's the version I'm going to do. Now, when I have a leading coefficient of 1, we do this really easily. All I do is I make my brackets. I'm going to go x, here's my first one, minus 3, x plus 4. How would you check it? Well, we do our double distribution. All right, so a plus b equals c for a leading coefficient. It goes pretty quick. So here you can see I've done the FOILed out. Now, by the way, if you're making your own problems, hint, hint, nudge, nudge, give yourself some problems that you make. It's important to start with this step. Not all trinomials are factorable. Okay, so there are some that are not, you can't solve them. So what's the technique? I do this little bit here. I go a times c, and they have to add to b. My a, just because you're learning, this is a, this is b, this is c. Many of you are going to go a times b and put negative 50 over on the c side. So just take your time. So a is going to be 1. My c is negative 50. 1 times negative 50 is negative 50. This is the number I'm going to be working with. So this is what I have to find. 2 factors of negative 50 that add up to negative 5. Negative 5. Okay. Now here's another one. So what are the ways that I can actually make a negative number when I'm adding? I could have a negative plus a negative. I can also have a bigger negative plus a smaller positive. Over here, remember, I have to multiply to give me what do I multiply? I have to multiply it to give me negative 50. So there's only one way for me to do that. I need a negative times a positive. Over here, the negative has to be the bigger number. So in the last one, what we did is we just listed all the factors of 50. I actually prefer to do it this way. I'm going to go 5 times 10. Then I'm going to go 2 times 5. Okay. So what I have here is I prime factored out my number. That one factors out really smooth, actually. And this is this technique I was mentioning called blocking. So now what I'm looking for is I need something that's going to add up to negative 5. Okay, but remember, these are all multiplied. So let's see what we can find out here. So first one is I can go 2 times 25. So that's 2 times 25. Well, you can see right away that that's not going to, if I add these up, that's not going to equal negative 5. Okay, so now we block a different way. I can go 5 times 10. Okay, so remember, I have to use all the numbers each time. So I get 5 and 10. Well, that equals 15. So how can I change it? 5 plus 10. Remember what we decided. It's got to be this one. I need a bigger negative plus a smaller positive. So I have my two factors. 5 plus negative 10 gives me negative 5. 5 times negative 10 gives me negative 50. I found my two numbers. Okay, they're positive for both columns. Check and check. So what do? We put them into some brackets. And because I have this a value is just x squared, that tells me that it's just x times x. So I'm going to go x plus 5 from here, and then x minus 10. And here, as I go back and check, I know I got the right answer. Okay, so this is how we factor out these trinomials. And as I mentioned before, what this tells us is that these are on a graph. The A, B, and C tell us very different things in this. I'm not going to get into that now, okay, because that's a different unit. The big thing is that we can now solve for these equations. So they actually tell us where this graph crosses that x-axis. All right, we're going to try one more that I'm going to make up to prove that sometimes they don't work. So let's go x squared plus 14x minus 11. So what do? What's the technique? Yell it out. A times C add to B. So my A is 1. My C is right here is 11. A times negative 11. I'm working with the number negative 11. My B is the number in the middle, the one with the x. So my B is going to be positive 14. So to make a positive, again, I have a negative plus a bigger positive, or I have a positive plus a positive. But can I use positive and positive? No. Why? Because this over here is a negative. So in order to multiply to get a negative, I need a negative times a positive. All right? And which one is going to be the bigger? It has to be the positive, because I'm adding up to 14. So here my factors of 1 and 11 are 1 times, 1 times 11. It's a prime number. So no matter what I do here, if I make the 1 negative, I get negative 1 plus 11. That gives me positive 10. I have no other options. So I can't find any factors that when I add them together are going to give me positive 11. So this can never equal positive 14 is what I meant to say there. Okay. So no matter what I do, I'm not going to find a number that is going to work in these. So this one here is insolvable. So that's why if you want to do these on your own, start with some numbers. X minus 11, x plus 22. You can make them harder. The bigger the numbers, the harder it is going to be to factor. So even these simple ones, they each take a couple of minutes each, at least. Okay, so this is a patient problem solving. That's it. Stay tuned for the how to solve 2x plus 4x, that should be squared, minus 16, something like that, where my leading coefficient is no longer 1. Good news, you start with the same technique. Okay, and then there's, I call it the shorts method, but you'll see that in my next video. Thanks everybody, hope that helps.